Hello and welcome to this channel. In this video, we're going to look at composite functions. So here's an example. Given that f of x is equal to 3x plus 1 and g of x is equal to 4x minus 1, find f of g of x. So whenever you see such, it means function composition. So this function composition, sometimes they can write f. So f of g of x can also mean f with a small o in between g of x. So this and this are the same. Okay, so let's go ahead and answer part A. So A, we have f of g of x. So they want us to find f of g of x. So you have to know that f of g of x is equal to the function f, then g of x, like this. So what it means here is that the function g of x is inside the function f. Whenever you have such a situation, it means that this function that is on the right is inside the function that is on the left. So in this case, g of x is inside the function f. So we can proceed and say f, what is g of x? G of x is this one. We've been given that g of x is this one. So we're going to put it inside. Here in the brackets, we have 4x minus 1. Like this. So just as I said earlier to say, this function is inside the function that is on the left. So the function f, it means that in the function f, wherever there's x, we're going to replace g of x. So the function f of x, or the function f, is this one. So we're going to say 3. I'm going to open brackets like this. Then there's a plus 1 there, plus 1. So here there's x here. 3, then there's x here. But now, where there's x, we're going to replace g of x. So we're going to say 4x minus 1. 4x minus 1. Then at this stage, we are going to apply the distributive law. We're going to multiply this term that is outside with everything that is in the bracket. So we're going to multiply it like this. We're going to expand. So 3 times 4x is going to be 12x. 3 times negative 1 is negative 3. Then plus 1, this plus 1 here. Okay? Next, we just have to simplify this. So we simplify this. We say 12x. Then negative 3 and 1 are like terms. So negative 3 plus 1 is negative 2. So we can now conclude and say, therefore, f g of x is equal to 12x minus 2. So this is the composition of the function f of g of x. Okay. Next, let's look at B. B, they want you to find the function, the composition function of g of f of x. G of f of x. So as I said earlier, here it means that you are going to have the function g, which is outside, okay, which is outside, then open brackets, f of x. So it means that the function f of x is inside the function g. So this function f of x, which is on the right, is inside the function g. So we can just go ahead and continue solving. We have g, f of x, the function f of x is this one. So we're going to say 3x plus 1. Okay. So now, when we reach at this stage, it means that in the function g, wherever there's x, we are supposed to replace 3x plus 1. So the function g is this one, which is 4. So I'm going to write 4, open brackets, like this. Then there's a minus 1 here, so minus 1. So here there's x, so I'm going to put this, you put this, so 3x plus 1, 3x plus 1. Again, you apply the distributive law. You multiply the outside term with everything that is in the brackets. You just expand there. So 4 times 3x is 12x. 4 times 1, it is 4. Then minus 1, this one here, like this. Okay? Then here you just simplify. So you have 12x. 4 minus 1 is 3. So you have 3. Like this. So you conclude and say, therefore, the composition of g of f of x is equal to 12x plus 3. So this is the composition of g of f of x. Now, when you compare the two, f of g of x and g of f of x are not the same. Here you have 12x minus 3, and here you have 12x plus 3. So in conclusion, in general, f of g of x, so we're going to say not, f of g of x is not equal to g of f of x. So you have to note this. If you have a function like this, it is not going to be equal to that. Okay. I'll see you in the next video. But before you leave, I encourage you to subscribe to my YouTube channel and also like my videos and also share. Goodbye. See you in the next video.